This is an opportunity, and we thank Chemtech and to be here. And the subject is subject is the most relevant for now. So what exactly is this? So my subject is energy quadrilemma, and before we discuss energy quadrilemma, what exactly is the oil and gas dilemma in the energy paradigm? So Mr. Girish just now referred to Occidental, and I have Occidental CEO Vicky Holub's quote, which says that fossil fuels aren't the problem, it's carbon emission. So decarbonization and the growth of oil and gas industry is the paradoxical dilemma evident in Holub's statement. Essentially, the global energy industry has a direct relationship with the climate, and the relationship seems problematic. As the world's primary energy resource, providing a basic, integrated, convenient, and connected progressive livelihood to human beings, it is at the same time confounding as to how severely it emits greenhouse gases to become the reason for ecological destruction. The dilemma is the helpless clash between the upwardly moving energy demands and the equally radical need to reduce CO2 emissions. The brief presentation following attempts to analyze the core business paradigms in our industry and attempts to discuss the dynamics of balancing approaches to address such a dilemma. To assess this difficult relationship and address a resolution, the World Energy Council coined the term energy trilemma and later added the people perspective as part of the assessing dynamics and devised energy quadrilemma, the two frameworks for resolving the main challenges posed by energy systems around the world. So the four quadrants of energy quadrilemma are cost, environment, security, and people-centric or populist stakeholding, and the eternal discourse over the whats and whys of oil and gas essential business produce. This is my thought. The dilemma essentially lies in our responsibility to responsiveness. Can we move? Sorry. Can we move, please?
Can you see the presentation?
Yeah, could you hear me for the
first
one?
Yes, I can.
Yeah, now, yeah. So I was just wondering, should I take it? Because we have 15 minutes and I'd like to do the sharing maybe.
Yeah, or, please. Yeah, I'll stop sharing.
Yeah, thank you. Are you able to see my screen? Are you able to see my screen?
Yes, ma'am, the screen is visible. Yes. Yes.
Yeah. Okay. Okay. Sure. For the quadrant one, which is the economics and cost, or I would call it cost as with a accounting a perspective, cost of sales or affordability. So for me, NEOM is an opportunity to create a template for what the world needs to be in the future. Gavin von Tonder, Executive Director of NEOM Water, says, a leadership that is creating footsteps for an entire generation, delivering 100% sustainability as an architect of a greenfield project of creating a country within a country, which is Saudi Arabia. So giving that reference for mature producing oil and gas industry, however, we often resort to coal or fossil fuel even to energize a PW treatment, produced water treatment facility. Energy that is cheap may not be good for the environment, like coal and gas, which is sustainable, maybe intermittent, which is solar. variable and insufficient to power industrial uses, which is renewable energy, and sustainable energy may not be locally available, leading to continued use of fossil fuels for self-reliance like energy security, which are all of these four are the energy quadrilemma. And when I say renewable energy is insufficient, I mean to say that biofuel has been in discussion since 2004, and we have in India, and we've still not been able to, and across the world, we have still not been able to resort to developing comprehensive biofuel to be able to compensate for the 20% of fuel ethanol usage. However, the good thing is that India has advanced their biofuel usage to by 2025, which is great, from 2030. So at this juncture, if we are able to create a template, which NEOM is creating, it's imminent that we retrace our steps backwards, since when things started becoming unsustainable for the environment and the society. And that could be tracing back to 1970, because that tends to be our benchmark for the carbon net zero, and device assessed technological intervention. For example, the EOR technology has been in practice for ages for reservoir productivity. However, for the first time, carbon sequestration and CO2 injection as emulsifier, as well as for displacing trapped fuel, is consciously used. The cycle potentially may start with capturing CO2 from the atmosphere via direct air capture or industrial sources. The injected CO2 in the producing oil and gas reservoir may be used as emulsifier or displaces the oil and gas trapped in the rock and facilitating or enhancing producing oil and gas, while permanently trapping the CO2 underground. So the statistical analysis of the production cycle shall elaborate that low, neutral, or even carbon negative produce, and moreover by sequestering an amount of CO2 equal to greater than that which is emitted. So essentially from European, Occidental, or ExxonMobil. Now, the attempt is obviously green or net neutral fossil fuel negatives with neutral CO2 emission. However, I would rather call it a blue rather than absolutely green, following Mr. Gradish's reference. Quadrant 2 is the
Your voice is gone, Subha.
Hello? Hello?
Yeah, you are audible now.
Okay. So the quadrant 2 is, I have an example of NEOM, how NEOM solar dome technology driving the desalination plant, and I have a reference to how the water and wastewater is providing. So the geodesic dome is the technology that's being used, and the water. So Saudi Arabia is a place which is without a place in the world, which is a river, and currently used for 100% sustainable renewable energy, which means that there is a dynamic difference between emission and emission reduction strategies, or leftover assessment and waste management philosophy. And I have been working with UR for this. For instance, management out of the non-revenue asset management. For instance, desalination plants are responsible for a combined output of 76 million CO2 per year. And the same goes for the PW treatment. So what oil and gas companies do to lower operational emissions? The energy used to power drilling and all the way to the trucks going to and from drilling sites, they do matter. And is working on multiple projects related to, so oil and gas industry is still currently working on multiple projects related to carbon sequestration, and not just for its operation, but other heavy emitters in the industry sector. The new and cheapest technology-based solar energy is slated to lower the emissions profile of oil and gas operations, and I'm very hopeful for it. And those who are visiting the Gulf Coast, some of you have joined from the US, and obviously ONGC, Videsh and ONGC, we are able to see the Permian Basin is, the solar over the Permian Basin is taking out, and it's very positive. The quadrant 3, security of energy supply. So this is a very familiar site. The AHSs are the seismic conditions.
Abhilash, can you please take over, because it seems we can't hear Subha at all.
Subha, do you want me to take over from here? Hello, Subha. Subha?
Hello?
Can you share the presentation, please?
Abhilash, you have the presentation.
Yeah, you want me to share it?
No, so I think, would you like to take over, or you could share it maybe, because maybe I'm not able to, I'm not audible, is it?
I'm not able to share it. Option.
Okay, am I audible?
You're audible now, but in the meantime, in between, your voice is getting breaked up.
Okay, so maybe very good 5G.
Is this visible now? Which slide do you want me to go to?
Subha, you are there?
Yeah, I am there. Am I audible now?
Yeah, you are audible. You have a problem with the connectivity.
Am I audible now?
Yes, you are.
Am I audible now?
Yes, you are.
Yeah, okay. So if we can just press the enter button here. Thanks, Mitra. This is an animated slide. If you can enter the button, press the enter button, please. I am. Yeah, can you press the enter button, please? Because it's an animated slide.
I don't see an enter button here.
On your screen, on your keyboard.
There seems to be a problem with this. There's no animation.
Okay. Okay, I'm sorry. Abhilash, are you able to take over?
I'm not able to share the screen. That is what the problem I'm facing. I'm so sorry.
So maybe you could just go on with your talk, and we can
I'll do that. I'll do that. Am I audible? Plus, am I visible? My screen. Okay,
yes,
I'll try to. Thanks, Abhilash. So this is a very familiar site. I'm talking about the one in sight, and that's what is happening across the world. And we, as oil and gas people, are very familiar. But what's on the left side is a robotics application, and RDS, the Robotic drilling system sets new standards with increased safety and cost-effective planning and drilling autonomous robotic drilling. So the robotics replace all those people. Plus, it sends out information that is going to be controlling the entire drilling operations and saving people, cost, as well as waste. This is implemented on existing as well as new drilling structures for both offshore and on land. So the energy security subject would be energy security as a philosophical concept has the built-in skepticism of turning into a moral value, and that essentially is not really a moral value. My perspective is that it is a revenue, it is definitely a revenue value. It has a monetary value attached. So oil fields mostly located in extreme conditions are posing serious challenges to both human and environment in terms of safety. Tasks which are repeated, dirty, and dangerous, but require high degree of accuracy are remotely operated and require highly skilled operator. Using robotics and removing human from hazardous environment benefits not only in terms of overall security, health, and safety, but also by getting such highly skilled resources to get involved in more significant deliverables. Using remote assets like drones or AHSs or digital twins, global project stakeholding becomes more relevant and definitely borderless environmental security responsibility. So assessing an asset valuation, including net book value as part of asset accounting, shall provide transparency to the cost of energy security or its non-conformance, essentially. Abhilash, am I visible now?
Yes, you are. Yes, you are. Go ahead.
Okay. So the quadrant 4 is the fourth element that the energy trilemma stayed short of, is the social dimension in energy. More suitably, the people or popular stakeholding. So I'll just make it very short. So sustainability must come at a reasonable cost to Mother Earth and humanity. And that basically is the focus. The goal, of course, has to be the customer stakeholding. And I have a very linear calculation, very straightforward. This is not really mathematical, maybe, but my simple linear calculation is considering the tailpipe emissions. So as per estimation, a typical passenger vehicle emits about 4.6 metric tons of CO2 per year, plus minus the variances. Now there are more than 1 billion fossil fuel vehicles on Earth, so emitting 46 gigatons of CO2 per year. What is the deficit target for net zero in 2030? It's estimated to be around 12 to 15 gigaton CO2 to limit global warming to below 2 degrees centigrade, which is the 1970 target, which is like going back to what we were doing in 1970. So for oil and gas industry, especially considering their customer, including cement, textile, and agriculture, which are the scope 2 emission accounting, the majority of the greenhouse gas emissions and cost reduction opportunities lie outside their own operations. NEOM, for instance, as a ground-up project, is aimed at eliminating scope 3 emissions. So this is what scope 3 emission accounting is, and the NEOM is planning to eliminate scope 3 emission altogether. And so Peter Terrum says that it is not about innovation because innovation is history, and it's about dreaming. So you can dream it, and my take is that, like Mr. Srivastava was discussing about the growth, and if we actually at this point of time when we are talking about growth, we can take pen and paper and look at the sustainability, do a sustainability accounting at every project. What we'll demonstrate is that not only this is technologically possible, but is also economically possible. And the moment we start doing that on an Excel sheet, this is possible. So it turns out that if we make a concerted effort to reduce or curtail, if not completely eliminate Scope 3 emission, we shall make a drastic progress in our growth towards net zero. Abhilash, it's you to take over. I'll if you want.
We have very less time. We have basically 2 minutes left out. I'll quickly go through through my part. So I'm basically presenting on the resiliency paradigm. Subha, can you please share the screen, please? Share the presentation, please. Don't stop sharing, please. So in this slide, what we are presenting is a produced water treatment plant, which was designed for 100% ZLD, but in reality, when it was being looked off, it was only 66% is the total outcome. So out of that 66%, there 44% is the loss. So to find out what exactly is the loss, we could identify that 23% is basically for the system or the process loss, and 11% is still undefined. So what can be the solution to rectify those losses is the bottling plant with water. We produce polysubstances. We use lithium. However, India is a lithium deficit country. So what we can use the other products which can be used for a raw material for fertilizers and all. We can have terrestrial agriculture. We can intervene with solar production. And lastly, we can use the IoT to determine the best solution with cost analysis of why this failure has happened. Please go to the next slide, please. Next one is a ZLD process where we are optimizing the reusability outputs. So the way we produce, and we must be a proactively simulated throughout decision, thought out the decision, valorizing every aspects of cost, environment, energy, security, viability, and social or people consideration must be worked out appropriately. So to achieve this, we have 3 stages. Stage 1 is the water that has been, we achieved that from the ETP, normal ETP plant. So on the basis of the TS and TDS, we will consider the specific use of the water. And in the second stage, we will evaluate the incremental cost on the ZLD, determining the distance from distance of disposal from the ETP output. And third one is the most important to have a successful ETP plant. Third one is the advanced planning for the reutilization of the solid waste. So solid waste, where we can use it. If we have a lot of solid waste, then there is no point of having a ZLD process. So solid waste are used basically as a salt in the textile industry. We can use it in agriculture industry, for the fertilizer industry, and if there is no any valuable minerals added in it, we can use it for landfills. Can you please go for the next slide, please? Quickly, I'm doing it a bit fast. So this is the final quadrant of final paradigm for the last quadrant, that is energy security and quadrant, where we are using the smart digital integration. These are some of the areas where you can use the smart digital integration as a resiliency paradigm for the quadrilemma that we have. On the right hand side top is a drilling, that is I-field components in the drilling used. Second one, if we go clockwise, anti-clockwise, the second one is the real-time situation analytics with prognosis prevent operational cost, hazard and security occurrences, and which in turn saves human lives. I mean, it saves human lives from the accidents and all that happens likely happens in the oil and gas industry. Then we have 3D geomechanics. We have I-field components for IoT integrated directional drilling, and we have simulations of well downhole assessment and all. So in a nutshell, these are the basically the resiliency paradigm for the quadrilemmas that Subha has just decided. So I'm very sorry I have to be fast because we are running out of time. Thank you so much for listening to us. Thank you.